authorized to navigate, deciding where they navigate to. These are all controller elements that people will very frequently, with JavaScript and other client-side technologies, migrate into the view for performance reasons, and then end up with client-side trust issues. So as you look at the structure of your application, just saying to yourself, well, what design patterns am I using, and what are the security implications and responsibilities of elements of that design pattern will be very helpful. And if the guys who built Spring had done that, we'd be in a different boat. Likewise, we have different expectations of the model. Interestingly enough, in our organization, when we do assessments, we have a checklist, literally, that goes along with the view, the controller, and the model. And when my consultants go out to do reviews, my hope is that each and every one of them will assign, basically, membership in the elements of the design pattern, the applications they're looking at, and then run that checklist. Are they doing authorization checks over here and not here? You know, are they allowing model update from the view as well, or from the controller as well? I know. Component diagrams are valuable because in my mind they provide, and especially when you've annotated them on top of things like this, because they provide you capacity to understand where your choke points are in your design. When you're talking about transferring between identifying what could go wrong and where the controls should be put in place, you're going to want to know where your choke points are, because that's going to help you make decisions to solve a problem one place as opposed to 2,000 places. So to Dennis's point earlier, if you have 2,000 SQL injections returned by a static analysis tool, do you have 2,000 problems to fix? Or is there a place in your design where you can abstract away input validation? Understanding where the frameworks sit and what behavior sits on top of them is fundamentally essential to any threat modeling exercise. Because no matter how much code is written in your application, unless you're really a do-it-yourselfer, and not invented here is your mantra, there's going to be more code underneath you than there is that you're responsible for. And in the example I've beat up, each of these frameworks has very, very rigid design assumptions based into it, and those have implications about navigation, about trust, about authorization that are important. And understanding where each of your components sits is going to be essential to understanding where assumptions may go wrong or not. If you have portions of your application that are built on top of a CG, you can make strong, fine-grained programmatic checks that are configured declaratively about your application, and you have a rich capacity to do authorization. But what about these other, these other beans that are not leveraging that? They basically, their security model is either hand-rolled programmatic or it's based on the deployment descriptor, and then the question becomes, is there access to them from a path that does not consider a CG? You can start to think about, in terms of the service to these components, whether or not they're providing security services to them up or down. Are some of these containers that are providing encapsulation, separation of address space, memory management, authorization to the components on top of them? In addition to where authorization and authentication decisions get made, just figuring out where the assets flow in the system is interesting. So one of the things we've started doing is starting to basically put a tick mark or put some icon in every module that has access to a particular equivalence class of data in its sensitivity. And it's really fascinating to see where some of those pieces of data flow. And what you'll find actually usually is that almost all the data flows everywhere. And so if you were to overlay a diagram like this with the diagram of where authentication and authorization decisions are enforced, you'd find a very fascinating mismatch, right? You'd find that, in fact, without fail, data is available where the authorization decision has not been enforced. In some sense, I'm starting to believe that just drawing a diagram with threats on it and having sort of the missile command from like 1980 something, these are all the attacks that could occur, is a failure mode. You know, people who have said, okay, well, this threat can do all of the OWASP top 10. Well, okay, so put those tests, in your test suite. Yeah, use a tool to find them. Let's think about, again, the logic problems and the misuses that can drive problems in the application, rather than muddying a diagram with a bunch of arrows. Now, the thing that's valuable about writing down the arrows in an application is very simply that you can begin to select exactly what you're going to attack in the application based on these arrows. So, for instance, if I have a threat that basically is sitting on the internet and I want to attack something, an asset in the database, we all know as common knowledge now that I'm going to use some type of SQL injection or command injection on the database, and I can start now to select if I've got misuses and I've got abuses of the application motivating concerns. I can start to select my attacks based on where they'll target, right? This is something that will be stored and another user will end up displaying in their browser and executing. This is something that will run on the actual web server. This is something that will run on the database. And so what's interesting about that is now that I have the capacity to target a particular tier based on these vulnerabilities, I can now start to get beyond this ridiculous argument about whether or not insiders matter or not, and talk about how people on the internet can target an aspect of the system. Okay. So they're telling me I have only 2 more minutes. So I guess what I'll wrap up with is the take-homes of this really is to base the threat model in the software architecture, not the network topology. To use specific uses of the application to begin to figure out what abuse of the application could entail in terms of vulnerability, and then what motivated misuse could entail. Use that also to inventory the assets in terms of data as well as privilege in the application, and start to map that onto the resolution at which you can do things like authorization and entitlement and dispatch of that functionality. You've got resources for the low-hanging fruit. Concentrate your threat modeling exercises on actually figuring out what goes beyond those checklists and what problems could exist in the logic of your software, the business logic. And use the directedness of the attacks to point out where targeted attacks can occur in different portions of the containers and the tiers. And by all means, use this as a mechanism to drive security testing and assessment, not as something that you end up with a threat model for the application and you're done. This is a planning exercise, not a conclusive exercise. My guess is that I left a lot of questions. And so if you're interested, I will be around to answer them. Also, these slides are available, and there's, I believe, 80 of them. So they are well annotated in terms of notes. So feel free to look through them afterwards and follow up with me. But I appreciate the attention. I guess I'll turn over to questions.
We don't actually have any time for questions, but if you want to kind of ask questions as he comes off the stage here, you're welcome. We're going to be setting up